Alrighty, howdy folks. Hey, we are moving on to chapter 4. Chapter 4 is all about comparing alternatives. So the motivation is something like this. Imagine you are some kind of a chief engineer, decision maker in a big firm, and you have a project. And let's say the project uh, is building an office for somebody. Now you can you can contract it out to somebody else. So you have two people trying to vie for it. So one person says, okay, it's going to cost you this much, and then the maintenance cost would be so much, and so on. And the other person will give the same numbers for them, what is suitable for them. So now you have to choose, hey, should I choose option A or option B? And that's a very, very common thing. Okay. And there are good ways of figuring out how to pick a particular alternative over the other. Okay. And one other important thing to notice is there is another alternative which goes without saying. And that alternative is what is called as do nothing. Right? That's also an option. So if all your decisions are simply based on financial things, then do nothing may be in fact a good idea sometimes. All right. Okay, let's see. Um, So in I'm I'm covering both sections 1 and 2 in this particular PowerPoint presentation, and it is all about present worth. Okay, let's look at this. The whole idea is to compare alternatives, and we are focusing on present worth. Okay. Man, this slide is full, completely full. Um, the 8 discounted cash flow methods used to compare investment alternatives are as follows. There are 8 ways you can choose an alternative. I wish there were fewer, but in fact, there are 8 of them, and believe it or not, you need to be familiar with all 8 of them. I think intellectually they're not very complicated, but you just need to be aware of all of them. And in fact, we will cover every one of those alternatives sort of in detail in this section, in this chapter. Okay, good. The first method is what is called the present worth method. Just without me reading anything, can you guess as to what the present worth method would all be about? So you have two alternatives. How do you figure out which alternative should you pick? Well, what is the present worth of each of them? Can we figure that out? Good. So whichever one has a positive and bigger present worth, that's what we'll pick, right? That's the whole idea. So now formally, how do we say this? The present worth method converts all cash flows to a single sum equivalent at time zero, right? Basically, finding the present worth, the net present value. One time we had done something like that. It's pretty much figuring out the net present value or the present worth of all the alternatives at t equals 0. What is that? And for this, we use an I value of minimum attractive rate of return. So this is sort of like the time value of money. Very first class, I had asked about, I give you $1,000. I borrowed $1,000 from you. Would you, if I gave you back 10,000, would you loan me the money? And you said, yeah, and loan me the money and I'll give it back 10,000. I'll give you back $10,000 a year from now. You'd say, yeah, of course, man. I'm making 10 times more money than I gave out. So that's good. And then I made it to 2000. Well, doubling is not so bad. So you might say yes. But then I said, how about 1100? Right. So at that time, we discussed something called time value of money. What is the time value of money for you? And firms have something called minimum attractive rate of return, which is nothing but the time value of money for them. Another way of looking at it is the firm itself could invest that money in a bank or something like that, and in a very good bank that gives them an excellent rate. So even if they do not invest in any projects or anything like that, if they happen to have some amount of money, they put that money in this bank and they can get certain money, right? And what interest rate would they get from the bank if they were to do that? And that is the minimum attractive rate of return for them. So now they are saying, okay, if we take up this project, would we get more than a return that is more than our minimum attractive rate of return? If so, we will actually take up the project. And so you calculate in this method, you calculate the present worth using whatever minimum attractive rate of return is for your firm. Okay. And then there is something called benefit cost ratio. Benefit over C, B over C method determines the ratio of the present worth of benefits and savings, that is the B, to the present worth of investments and costs using I equals minimum attractive rate of return. A variant of this is to find B minus C. Okay, let's see what that means. For a project, would you agree that there would be some benefits in the sense, if you build a restaurant, you'll be making some money, right? So that is the benefit. And if you already had a restaurant and you built a new one, so in both cases you had benefit, but the newer one, you have automatic dishwashing machines. So you don't have to employ some people for that. And as a result of that, and also you have some nice LED bulbs as opposed to the previous one had different kind of lights, and so electricity was expensive. And so there would be some savings because of this new project. So benefits and savings is what you call B. Find the present worth of all the benefits and savings, and then do the same thing for the investment. Of course, you need to invest some money, right? That's a cost. And on top of it, there might be something like maintenance costs. And for different options, you may have different maintenance costs. You can see that, right? So you take all the investments and the costs and figure out the present value of that using this I equals minimum attractive rate of return, MAR. Okay. And that's how you determine which alternative you should pick. Benefit cost ratio, it is called. We'll get in detail, in depth into this. The whole idea here is to give you an idea of each one of them so that you kind of get an idea, and you'll get a much deeper idea when we go deep. And the third option is the discounted payback period. Discounted payback period, DPBP method determines how long it takes for the cumulative present worth to be positive using I equals minimum rate of return. Okay. Look at this one. What is that? How long it takes for the cumulative present worth to be positive using I equals minimum attractive rate of return. Can you imagine something like that? Okay, check this out. If you invest $10,000 on a project at t equal to 0, money has gone from your pocket. What was your hope? Well, as a result of this investment, I'll start making some money, right? Okay, um, well, I think I can make it even simpler. You deposited $10,000 in a bank. After that, one year later, you get some money. 2 years later, you get some more money. So every year, let's say you're getting some money. But would you agree that if you invested 10,000 and you were getting $1,000 every month, every year, after the first year, you are at a loss. You are at a negative. In the beginning, you are at a negative because you have a $10,000 investment. After 1 year, you got $1,000 back. Find the present value of that and subtract from the 10,000, but that is still a negative. 2 years later, you are still under a negative. But at some point of time, as you keep calculating uh, the net present worth, you will see that you are no longer in the negative. In fact, your present worth is just turned positive. Can you see that? So that there is a way of calculating how many periods, how many years is that, so that the negative cumulative present worth turns into positive. And that's another way of figuring out which alternative is better. So, for instance, let's say there are two alternatives. Both of them you invest $10,000, but one of them turns positive in 5 years itself. And the other one takes almost 8 years to turn positive. In that case, obviously, 5 years is quicker, so you will pick alternative A. That's all this is trying to say, the discounted payback period. Cool. Capitalized worth method determines the present worth when the planning horizon is infinitely long. So capitalized worth is kind of like the present worth. It's just that, the planning horizon is infinitely long. Whereas in the present worth, you have a finite amount of time. The planning horizon is just finite. Whereas in the capitalized worth, it's infinitely long. Okay. Um, I'll show you some examples of where that would be. The annual worth method converts all cash flows to an equivalent uniform annual series of cash flows over the planning horizon using I equals mar. Kind of like the present worth, figure out the annual worth of each one of them. That A, uniform series stuff that we did. So find that A and compare them. The one that with a bigger annual worth is the one that you want to go with. Okay. Future worth. I'm sure this is fairly straightforward. Just as we found present worth, you could convert everything to the future and see which one is bigger and base your decision on that. And then here comes the internal rate of return. This is very, very important. I told you a story about my friend who works for a gas station, not gas station, a big oil farm, oil and gas firm. And so he said they actually use this internal rate of return method. So what is that? Rate of return method determines the interest rate that yields a future worth of zero. Right? Is the interest rate that yields a future worth of zero. The truth is, if the future worth is zero, well, what happens if you take the future worth of zero and project it back to the present worth? Duh, that would still be zero. Okay, if you take the future worth and split it to a uniform series, what would be the uniform series payment? That would also be zero. So even though we call it as future worth of zero, you can pretty much say present worth of zero, annual worth of zero. Okay, what is this now? Internal rate of return, interest rate. What interest rate makes this into a future worth of zero? Isn't that interesting? Uh, I think I'm trying to see if I can give a quick example of it, but I think I'll wait. Okay. External rate of return, there's another method, that's the final method, determines the interest rate that equates the future worth of the invested capital to the future worth of the recovered capital when the latter is found using minimum attractive rate of return. Hmm. The external rate of return, what that method does is interest rate that equates the future worth of the invested capital to the future worth of the recovered capital. Hmm. Okay, I'll tell you what. When we get there, I think a simple example is not so easy to give at this point of time for me. So let's move on, and when we get there, what's that American expression? We'll cross the bridge when we get there. I like that. We'll cross the bridge when we get there. Cool. Using present worth. One way of comparing two or more alternatives is to compare the present worth of those alternatives. Uh, yeah, we already covered a few such cases in the previous sections. Now let's look at I like this example for some reason. The owner of a cemetery plans to offer a perpetual care service for grave sites. The owner estimates that it will cost $120 per year to maintain a grave site. If the interest rate is 8%, what one-time fee should the owner charge for the perpetual care service? Isn't this interesting? Try to understand what this is trying to say. Something like a grave site, right? It has to be maintained. For how long? Forever. And and whoever owns that graveyard will say, okay, we can give you forever service. We'll clean up the gravesite, and we'll let you come and do your stuff every year, whatever, whenever, all that stuff. They will guarantee that they'll do that for you. But obviously it's going to cost them money, and so they need to make some money off of you also. So they say, okay, let's say it costs $120 per year to maintain a gravesite. Of course, realistically, you could expect that with inflation and all that, it probably won't stay the same $120. But for simplicity, let's assume that it is always $120 per year to maintain the gravesite. Okay. Now, the guy needs to charge a one-time fee at the beginning. You do this, and I'll take care of it for the rest of life. Right? Can you do that? The answer is yes. We can figure out answers to questions like that. Recall that the formula for the present worth, given a set of periodic investments or receipts, is P equals 8 and shucks. I should have made it into separate ones. So the present worth is equal to A times our good old formula 1 plus I to the n minus 1 over I times 1 plus I to the n, right? So that's the one. So what P should he charge? So that A is $120, and now what should N be? Perpetual. So there is no limit to this number of years. So infinity, whether whether the whole earth will last for infinite number of years is a different story. But theoretically, at least, we need to assume n to be infinity. So what do? You always take the limit, right? If n is approaching infinity, the only way to do these kind of things is by taking the limit as n approaches infinity. Let's look at this guy and see, can we find the limit of this as n approaches infinity? So 1 plus I to the n will be infinity, will approach infinity as n approaches infinity. Infinity minus 1 is still infinity. So on the top you have infinity. I is some finite number times 1 plus I to the n. That also goes to infinity. Infinity times a finite number in the bottom, that is also infinity. So we have infinity over infinity. What do we do typically when we have infinity over infinity? The French guy, l'hôpital, El Hospital. The l'hôpital guy, so we'll apply the l'hôpital's rule. Or look at this cool trick we can do. Can I split this into two fractions? A minus B over C as A over C minus B over C. So this becomes 1 plus I to the n over I times 1 plus I to the n minus 1 over I times 1 plus I to the n. Okay, but 1 plus I to the n and 1 plus I over to the n cancel out. So that first term becomes 1 over I minus this. Now, can we find the limit as n approaches infinity? Yes. Check this out. The denominator goes to infinity, but the top is 1. So 1 over a very large number as the limit is equal to 0. So when you take the limit of this, all you get is a times 1 over I. Okay. So that is it. So in this case, 120 over point is $1,500. So if he charges $1,500, the cemetery guy, then he can keep on maintaining this for infinite amount of time. As simple as that. Right? I like this problem. Oh, by the way, a similar thing happens when there's something called endowment scholarships. For instance, in our math department, there is something called Dolzilski scholar Richard Savage. Okay, Richard Savage scholarship, Dr. Richard Savage scholarship. So Dr. Richard Savage said, "Okay, I want the department to give $1,000 scholarship every year. For how long? Forever. Okay. So, how much should Tech ask Dr. Uh, Dr. Savage to pay in the beginning so that this can go on? Oh, you want $1,000 to be given away every year? Cool, 1,000 divided by what is our rate of return? So Tech will ask, or the math department will ask, what is our rate of return? If it is 10%, then $1,000 divided by 10%, so $10,000, right? So, so that's another case. That's another place where this sort of perpetual thing stuff works. Okay. Consider a palletizer at a bottling plant that has first cost of $150,000, operating and maintenance costs of $17,500 per year, and an estimated net salvage value of $25,000 at the end of 30 years. Assume an interest rate of 8%. What is the present equivalent cost of the investment if the planning horizon is 30 years? Cool. Just to buy the equipment and everything, it costs $150,000. And after that, operating and maintenance costs, they add up to $17,500 per year. But at the end of all of this, you get to salvage this. What you bought for 150,000, you don't have to just throw it out. You can sell it and you can still make $25,000. Okay. What is the present equivalent cost of the investment is what the question is about. So let's see. Would this diagram explain what's going on? 150K initial investment, and then every year there is 17.5K costs, operating and maintenance costs, and finally there is a positive 25,000. F in this case is 25,000. What is the net present worth of this one? Present equivalent cost. Now, before we do that, uh, these are annual maintenance costs, right? 17,500. At the end of year 30, you want to sell it. and get for the salvage price. Please pay attention. At the end of year 30, you want to sell for the salvage price of 25,000. Well, if you're planning to sell it at that time, would you still incur the maintenance cost of 17.5K that year? That's what I'm asking. Should there be the 70,000 maintenance cost shown at t equals 30? The thing is, answer is yes. Because imagine that you're planning to sell your car at the end of the year. Would you stop doing the maintenance work that year? No. You're planning to sell it at the end of the year, so the whole year you would be maintaining it. You are using it, and so you would need to maintain it, right? So, yes, it makes sense to include the maintenance cost even at t equals 30. Anyway, and then all these calculations are the ones that you're quite familiar with. The present is negative 150K and A is 17.5. It's all negative, but the 25,000 is a positive. So we do this and then we end up getting minus 344,526.77. Just this alone will cost you $344,526.77. Present equivalent cost. Of course, what they are conveniently neglecting is, as a result of this bottling point, of course, would you be making some money? Of course, you'd be making tons of money. We are not talking about how much money you are making. We're just trying to find what the present equivalent cost is. Okay? All right. GeoWorld Systems uses a subset of the following questions during the interview process for new engineers. Ooh, I like this. For each of the following cases, determine if the project or do nothing is preferred. The value of minimum attractive rate of return in each case is 14%. For FE exams, these kind of questions are very, 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 very important. These are all simple questions. The present worth of the project is 1,367. Should you do the project? Or should you do nothing? Which one is better? What do you think? With the do nothing, what is the present worth? Zero, right? So because you are not, why do I say present worth is zero? Because you're not doing the project, so you're not incurring any cost of that project, nor are you gaining anything from what the project would give you. So the do nothing operation as a comparison has zero net present worth. Whereas the doing the project gives you a present worth of 1,367. All you care about is it greater than zero? And so we prefer doing the project because the present worth is a positive value, right? Compared to zero, positive is better. So that's why we will do the project. We should do the project. The internal rate of return of the project is 12.9%. Right? If you take the project up and you calculate what would be the rate of return you would get for this one, you get 12.9%. So should you do the project? Remember, the minimum attractive rate of return is 14%. That is, if you were to invest in quote unquote a bank, you are getting 14%. Why would you take this project and all the headache the project has to only get a 12.9% rate of return? You wouldn't. So, in other words, prefer to do nothing since I is less than this internal rate of return is less than the minimum attractive rate of return. Right? Cool. The annual worth of the project is negative $632. Annual worth. So what you've done is you figured out the present worth of this and smeared it out for every year, like a uniform distribution. If you do that, you get the annual worth apparently to be negative 632. Well, isn't that bad? Yeah. That is definitely bad. So we prefer to do nothing since the annual worth is less than zero, is a negative one, negative value. Okay, the benefit cost ratio of the project is 1.08. What do you think? Benefit is on the numerator, cost is in the denominator. And that is equal to 1.08 on the numerator and 1 in the denominator. So benefit is 1.08, cost is 1. Looks like benefit is bigger than the cost, right? Proportional to. So definitely you should do this. So prefer doing the project since BC ratio is greater than 1. The future worth of the project is $3.75. Well, the truth is we don't care whether it is 375 or $3.75 or not. That may be a small project, but we have to do this project. We are prefer to do the project because the future worth is greater than zero. Just like the present worth was greater than zero allowed us to do the project, future worth of positive is also a good option. The external rate of return of the project is 15.3%. Well, that's bigger than the minimum attractive rate of return, so we do want to do the project. Finally, for cases in which do nothing was preferred, what assumption is being made about the return generated by the uninvested funds? Okay, that the assumption is that the uninvested funds would be invested in other ways that would fetch the minimum attractive rate of return. I say bank, but what I mean is it could be anything. You may have a sort of a sure shot way of getting minimum attractive rate of return. So you would prefer to do that, right? Which is the do nothing operation. Okay. Now let's look at this problem. Durotech Manufacturing is evaluating a process improvement project. The estimated receipts and disbursement, payment basically, associated with the project are shown below. Minimum attractive rate of return is 6% per year. Answer the following. Look at this. End of year 0, you get 0 receipts, but you're spending 5,000. End of year 1, you still receive 0, but you pay $200, some kind of a cost. However, the moment year 2, the end of year 2 happens, oh, you do get some money, $2,000. And after that, 4,000 and so on. Anyway, you get the idea. So what's the question? Answer the following. What? Should your tech implement the proposed process improvement based on present worth? Right? So it's simple. Find out the present worth. Is that greater than 0? Then you do the project. Right? So without much further ado, present worth is, let's take this guy. That is a t equal to 0. So negative 5,000, negative 5,000 because it's a disbursement. And here the total is 0 minus 200 after at 1 year. So push that back by 1 year by doing 1 plus 0.06 to the negative 1. 0.06 is the 6% per year minimum attractive rate of return. However, year 2, to push this forward to t equal to 0, understand that there is a plus 2000 and a minus 300. So that's exactly what I'm doing here. Plus 2000 for the receipt and 300 for the minus 300 for the disbursement. And that needs to be pushed back to year 2. And we keep doing that for every other year. 4,000 minus 600 times 1.6, 3,000 minus 1,000 times negative things, negative 4, blah, blah. So all of this turns out to be $837.93. All we care about is this is a positive value, so they should implement the proposed process improvement. Cool. Next, a firm is considering buying a new machine. It has a first cost of $100,000 and a useful life of 15 years. At the end of its useful life, the machine has no salvage value. Annual labor costs would increase $2,000 using the machine, but annual raw material costs would decrease $12,000. Minimum attractive rate of return is 5% per year. Should the firm buy the machine? Cool. And once again, we didn't mention this, but because we are in the present worth thing, we'll find the present worth of all of this. First cost of 100,000. Would you agree that should be a minus 100,000? Good. After that, what happens? Annual labor costs, the A thing, uniform. Labor costs increase 2,000, so minus 2,000, but the annual raw material cost decreases, so that's a gain. So we'll say 12,000 minus 2,000, right? And then the formula 1 plus I to the n minus 1 over I times 1 plus I to the n. I happens to be 0.05 and n happens to be 15. So do that and we got this. And there is no salvage value. Otherwise, we would have taken the salvage value and pushed it to t equal to 0. But since there is no such thing, this turns out to be 37, 96, and 58. So should the firm buy the machine? Yes, they should. Since the present worth is greater than 0, the firm should buy the machine. Which alternative should be chosen if minimum attractive rate of return is 10%, planning horizon is 3 years? So there are two alternatives that look like this. Which one should we choose? Can we find the present worth of both the cases? Present worth of A, alternative A, is 3,000. That's the negative, plus 2,000. Find the uniform series, minus 3,000 plus 2,000 uniform series formula apply for the present value of the uniform series. And this turns out to be 1,973.70. And the same analysis for B gives you 2,460. So which one should we pick? We should pick alternative B, right? Cool. Let me ask you one question, because this is pertinent to what we are about to do right after this. What if the interest rate is not 10%? Instead, the interest rate is just 0, right? Interest rate is 0. Aha. Then, how do we interpret this first one? First cash flow diagram. Negative 3,000. If you push this back by 1 year, what would its value be? It's a plus 2,000 at t equals 1. If you push it back, and to push back, what do? We multiply by 1 plus I to the negative 1. Now I is 0. So 1 to the negative 1, which is 1. So 2,000 times 1, that's what you would do because I is 0. And for this one, 2,000 times 1 square, that is still 2,000, 2,000. So the answer is very straightforward. Negative 3,000 plus 2,000 times, there are 3 of them, 2,000 times 3. Does that make sense to you? If I is 0, then all you do is, these are equal payments. So 2,000 times 3 is 6,000, and this is a minus 3,000, so 6,000 minus 3,000. And similar thing for this one, 3,000 times 3 minus 5,000. That is the present worth if I is 0. I want you to know that part. Okay, cool. Next, in the previous problem, clearly alternative B is better, right? That's what we saw. because it's 2,460. We saw that B is better. Now, for a different minimum attractive rate of return, would alternative A be better? When I first saw that question, I was like, dang, I didn't even think about that. Right? Is, 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 is it all dependent on this I value? Right? Well, what about the case of zero? I is zero. What did we say? 6,000 minus 3,000 is 3,000, positive 3,000 for option A. 9,000 minus 5,000 is 4,000. So what is that? 6,000 for alternative A, 4,000 for alternative B. So notice for I equals 0, alternative A is better than B. Oh, so at least there is one case that we have found where, depending on a different I, alternative A seems to be better than B, right? So, so what is that particular value of I where, this option is to the left of it, that option is better, to the right of it, this other option is better. And for that, we have to plot. We'll plot the present values of both alternatives for more between 0 and zero point 0.8. Zero point 0.8 means what? 80%? Whoa, Nelly. Ah, can the minimum attractive rate of return be 80%? That is less likely to happen, but yeah, okay. So stopping ourselves at 0 0.8 is not a bad idea. So what is this present? So what I did here is I went to GeoGebra and plotted this equation. Minus 3,000 plus 2,000 times 1 plus I cube minus 1. So all of that I plotted here. So I value on the x-axis or the abscissa and the present worth in the y-axis or the ordinate. Abscissa and ordinate. And the present worth is in thousands of dollars. When I did, got 4,000. This red is 4,000 alternative B initially, and then it starts to go down. And alternative A is the green one, and that starts at 3,000 and starts to go down like that. What? Somehow this graph should tell us the answer. For a different minimum attractive rate of return, would alternative A be better? Can we answer that question here? Of course we can. Look at this intersection point of those two curves. That turns out to be 0.23. You have to take it from me. Okay, what is the significance of that intersection point? To the left of it, to left of 0.23, that is at 0.2 or 0.1 or 0.15 or any value less than 0.23, the red has a higher value than the green. So that means alternative B is better from an interest rate of more of 0 to 0.23. But after 0.23, the green is higher, right? Green is above. So green is better. Cool. Um, that is something we can clearly see. So it is that is for a different MOR, the answer is yes. For a different MOR, a minimum attractive rate of return that is greater than 0.23, definitely alternative A is better than B. Cool. But just a small word of caution. I said for I greater than 0.23, alternative A is better. But then if you follow each of these curves, uh, they are going into the negative territory at some I value, right? For a minimum attractive rate of return of what looks like some 0.38 or something, and this one at something like a 0.45. After that, they are both going to into the negative territory. What does that mean? That means for those minimum attractive rates of return, the present worth is actually negative. So what should we do? Should we still do? Okay, for a point 0.4 greater than 0.45, would you agree that still alternative A is above alternative B? So would you say that we should pick alternative A? The answer is no. What? Clearly, alternative A is above alternative B, man, so we should pick. But remember, there is a third option, the do nothing operation option, right? The fact that these are negative means do nothing is better than these alternatives, right? Mind blown. Um, Wonderful analysis. And these are the kind of things that you really, really would be doing in your analysis as an engineer. So, welcome to the real world. According to the graph, is that correct? Yes, because I explained this and okay, anyway. So well, another approach is I looked at this stuff and I said, if I plug I equals 0, what happens? Right? Then the problem is you get 1 plus 0 is 1, 1 cube is 1, 1 minus 1 is 0, and 0 times 1 cube. So we have a 0 over 0. So I got curious. I said, can I apply L'Hopital? Yeah, I applied L'Hopital, and lo and behold, what happens is this turned out to be, if you take the limit of this as I approaches 0, you get 3, right? 3 times 2000. Wasn't that what I was saying? When the interest is 0, all you do is 3 times 2000 because there are 3 equal payments. So similarly, the other one also will give you a factor of 3. So 3000 times 3. That's the point I'm trying to make here at the end. Another approach is this one, which gives an indeterminate form 0 over 0. And by applying L'Hopital's rule, we get the multiplying factor of 3. Okay? Wonderful problem. Let's see. A few more interesting. Yeah, that's the one. So the two graphs intersect at a MAR of 0.23. So that means when MAR lies between 0 and 0.23, alternative B is better. But beyond that, alternative A is better. However, um, at 0.45, you are better off doing nothing. As long as we are in the positive territory, that option is better than the do nothing. But the moment you dip into negative territory, well, do nothing is better. Okay? Negative values, so those means do nothing is a better choice. Amigos y amigas, adios.